Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You could even call your aunt who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. US Cellular, built for us. Visit your US Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
With Starbucks Holiday Blend for Nespresso Virtuo, now exclusively at Target, there are even more ways to share the joy. Savor every smooth and festive sip all holiday season with friends and family at home to fill every indulgent day with cheer.
This is SpaceTime, Series 26, Episode 10, for broadcast on the 23rd of January, 2023. Coming up on SpaceTime, what brought the dwarf planet Ceres to life? Lonsdaleite in the sky with diamonds, and failure for Britain's first orbital rocket launch from home soil. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that the radioactive decay of some elements could account for all the heat needed to drive active geology early in the history of the dwarf planet Ceres. At 945 kilometres, Ceres is the largest spot in the main asteroid belt between Mars and Jupiter. But even though it contains a full third of the mass of the entire main asteroid belt, it's still so small it was always assumed to be inactive. The belt includes hundreds of thousands of asteroids spanning the snow line, the distance from the Sun where it's cold enough for volatile compounds such as water, ammonia, methane, carbon dioxide and carbon monoxide to condense into solid ice grains. And Ceres appeared indistinguishable from any other main belt asteroid in early telescopic observations from Earth. But all that changed in 2015, when this hazy orb suddenly came into sharp focus, thanks to the spectacular observations undertaken by NASA's Dawn spacecraft. All of a sudden, Ceres became a real world, and one quite unique. We now know the dwarf planet appears to be differentiated to a rocky core and an icy mantle, and it may even have a remnant internal ocean of liquid water hiding under its icy crust. Ceres' surface is a mixture of water ice and various hydrated minerals such as carbonates and clays. The data and images collected by Dawn have given a clearer picture of the dwarf planet's surface, including its composition and structure, and it's also revealed unexpected geological activity. See, Dawn's discovered a large continental-sized plateau on one side of Ceres, which actually covers a significant fraction of this frozen world. Surrounding it were fractures in rocks, all clustered in one location. And there were visible traces of an ocean world, thanks to deposits all over the surface where minerals had condensed as water evaporated, evidence of a freezing ocean. And all this raises the question, where did Ceres get the energy to allow for the kind of geological activity that could account for the surface features seen by Dawn? A possible answer is in a report in the journal AGU Advances. It concludes that the heat needed to keep a small world like Ceres active could be found in the decay of radioactive elements within Ceres' interior. The authors of the study reached their conclusions following detailed computer modelling. The study's lead author, Scott King from Virginia Tech, says studies of big planets such as Earth, Venus and Mars have shown that planets all start out hot. Collisions between objects that form planets creates this internal heat. But in contrast, Ceres simply never got big enough to become a planet, generate the heat in that way. To learn how Ceres could still generate enough heat to power geological activity, King and colleagues used theories and computational tools previously applied to bigger planets in order to study the dwarf world's interior. They then looked for evidence that could support their models in the data returned by the Dawn mission. The team's model of dwarf planet interiors showed a unique sequence. Seems Ceres started out cold, but then heated up because of the decay of radioactive elements such as thorium and uranium. And this alone would have been enough to power geological activity until the interior became unstable. King says he then noticed that all of a sudden one part of Ceres' interior would start heating up and moving upwards, while another part would be moving downwards. And it's that instability which could explain at least some of the surface features that have been formed on Ceres as revealed by the Dawn mission. The large plateau that formed on only one side of Ceres with nothing on the other side, and the big fractures that all clustered at just one location around it. The concentration of features in just one hemisphere signalled to King that instability had occurred and had left a visible effect. King says it turns out he could show through the modelling that where one hemisphere had an instability that was rising up, that would cause an extension at the surface, and that was consistent with the patterns of fractures seen on Ceres. So based on this model, Ceres didn't follow a typical planetary pattern, hot first, then cold later. But instead it had its own pattern of cold first, then hot, and then cool again. King says it shows that radiogenic heating all on its own is enough to create interesting geology. He sees similarities to Ceres in the moons of Uranus, which a study commissioned by NASA and the National Science Foundation recently deemed a high priority for a major robotic mission. NASA's Dawn spacecraft was launched back in September 2007 on a mission to explore the two worlds of Vesta and Ceres, the two largest bodies in the main asteroid belt between Mars and Jupiter. The 1,218-kilogram spacecraft achieved orbit insertion around Vesta in July 2011. Vesta is by far the brightest asteroid visible from Earth, and it contains some 9% of the total mass of the main asteroid belt. The 525-kilogram wide world has a differentiated internal structure typical of terrestrial planets, with a metallic iron-nickel core surrounded by a rocky mantle. Then, after 14 months of surveys, Dawn left Vesta and travelled to its second target, the dwarf planet Ceres, arriving there in March 2015. Dawn studied Ceres until October 2018 when it ran out of fuel, and it remains in orbit around the frozen dwarf world. This is SpaceTime. Still to come, Lonsdaleite in the sky with diamonds, and failure for Britain's first orbital rocket launch from home soil. All that and more still to come on SpaceTime. Scientists searching for meteorites in outback South Australia are finding diamonds embedded in the space rocks. These are microscopic grains. They're known as Lonsdaleites, and they reside deep inside Uranite meteorites. Lonsdaleites are a rare hexagonal form of diamond crystal, and these are now thought to have originated in the mantle of an ancient dwarf planet which was hit by an asteroid around 4.5 billion years ago. Lonsdaleite is named after the famous British pioneering female crystallographer Dame Kathleen Lonsdale, who was the first woman elected as a Fellow to the Royal Society. A team of scientists carried out a series of tests trying to determine how Lonsdaleites formed. The authors used advanced electron microscopy techniques in order to capture solid and intact slices of meteorites to create what are really snapshots of how Lonsdaleite and regular diamonds are formed. Their findings, reported in the Journal of Proceedings of the National Academy of Sciences, PNAS, suggest that Lonsdaleites are formed in very different ways to other diamonds. And during their analysis, they also discovered what are now considered to be the largest Lonsdaleite crystals known to date. These are up to a micron in size, still much thinner than a human hair. The authors say they think there's strong evidence that there's a newly discovered formation process for Lonsdaleite crystals as well as regular diamonds. This would be like a supercritical chemical vapor deposition process that has taken place in these space rocks, probably in the dwarf planet, shortly after a catastrophic collision. And that's interesting because chemical vapor deposition is one of the ways humans make artificial diamonds in the laboratory. essentially by growing them atom by atom in a specialised chamber. The study's lead author, Professor Andy Tompkins from Monash University, says the hexagonal structure of Lonsdaleite's atoms makes it potentially much harder than regular diamonds, which have a cubic structure. The unusual structure could help inform new manufacturing techniques for ultra-hard materials, especially in things like mining applications. Tompkins says Lonsdaleite in meteorites form from a supercritical fluid at a high temperature but at moderate pressures, almost perfectly preserving the shape and textures of the pre-existing graphite. He says that later it was partially replaced by diamond as the environment cooled and the pressure decreased. Tompkins thinks Lonsdaleite could be used to make tiny ultra-hard machine parts. That's if they can develop an industrial process that promotes replacement of pre-shaped graphite parts with Lonsdaleite. But he says the important thing is that the study helps address the long-term standing mystery regarding the formation of different carbon phases in Ureilite meteorites.
These are diamonds we found in Ureilite meteorites, one of the largest group of achondrite meteorites that we have in the global collection. Scientists have known about the diamonds in Ureilites for quite a long time, but there's been a long debate about how the diamonds might have formed. Sort of the long thought idea is they formed at high pressure when there was a big impact that disrupted the Ureilite parent asteroid, and we're suggesting a new way that they formed by a sort of a mechanism that's similar to the way they're made today in the lab.
How are they made in the lab these days?
Okay, so a lot of the time in the lab they're made by a process called chemical vapor deposition. And the way that works is they use a little seed diamond, like a tiny little diamond particle, and then they grow more diamond on top of it. And they do that in a low pressure atmosphere that's hydrogen and methane and carbon monoxide. And the methane has carbon in it, so the diamond literally goes from the carbon and the gas onto that seed diamond. So that happens at very high temperatures, 1,000 degrees plus, and low pressure, so less than 1 atmospheric pressure. And we're suggesting a similar sort of thing happened inside the meteorite as the asteroid was disrupted by a large impact.
And that's very different to the way diamonds are normally formed on Earth, usually in giant vents.
Yeah, so on Earth, they normally form in the mantle around about 150 kilometers down, and they're brought to the surface by volcanoes, and they're mined in Africa and Australia and Canada and lots of other places as those vent deposits of diamonds brought up in the lava.
You studied the unusual structure of the diamond.
Yeah, so I was just actually looking down a microscope at these diamonds just to try and understand them a little bit better, and we found these unusual fold shapes, so looking like bent crystals of diamond. Diamond's really, really hard, so the immediate thought comes to mind, how on earth could you possibly fold diamonds? It's the hardest thing we know. And so we did a little bit more work, sort of delving into what could be going on here with the electron microscopes at CSIRO and the transmission electron microscope at RMIT, and found out that the diamond was actually a hexagonal diamond called Lonsdaleite. So it's a little bit different to normal cubic diamond that we're used to thinking about in diamond rings and that sort of thing. This one's hexagonal and maybe even a little bit harder than regular diamond. So we were able to sort of map the distribution of Lonsdaleite and normal regular diamond in the meteorites using some of these electron microscope techniques. So that was we were able to make some pretty cool maps out of that process.
Are all Lonsdaleite diamonds from extraterrestrial sources?
I think they've been able to make some in the lab as well by chemical vapor deposition.
Right.
But
in nature?
they haven't been able to, the ones in nature they've been able to find in meteorites and other meteorites as well.
And the other exciting thing is their extraterrestrial origins. This is where dwarf planets in our area of the universe comes in.
Yeah, so the idea is we think that the Ureilite parent body was quite large, and if it was larger than about 500 kilometres, it would have been probably just getting into the sort of size range where it could start forming a spheroidal shape. But something like Esther is sort of bordering on being a dwarf planet, and Ceres is a dwarf planet, sort of thing. So they're the biggest asteroids in the solar system. Yeah, and so the Ureilites are thought to be from the mantle of a dwarf planet, so or a very large asteroid. We're not quite sure how big it was. So they come from very, very deep down beneath the surface, and they were sort of liberated by a gigantic impact that happened about 5 million years after the asteroid first formed.
Our listeners may have noticed that you're fading in and out, and that's because you're at a really interesting place right now. You're basically on the very edge of the Nullarbor Plain in outback South Australia, near Old Deer. Tell me about it. What are you doing there?
Yeah, so we're on the Nullarbor and to try and find more meteorites. Nullarbor is probably the best place in Australia to try and find meteorites because it's this large limestone-covered plain in a sort of a desert sort of environment. So limestone's good because it's a white rock and meteorites tend to be dark. So it can walk around across the desert for many kilometres and pick out all the dark rocks amongst the light-coloured rocks, and the darker ones have a good chance of being meteorites. And then the desert environment is good because the low rainfall means the meteorites don't weather away and rust away and be destroyed over time. And they don't get buried by sediments either. So basically what we do is come out here every year and try and find some more meteorites. And we have quite a large collection of meteorites from the Nullarbor now. That's where most of Australia's meteorites have come from. We even have found Eurolite meteorites in the Nullarbor as well. They were included in that study we've just published. So you get some pretty cool science results out of the meteorites we find here.
That's Professor Andy Tompkins from Monash University. And this is SpaceTime. Still to come, failure for Britain's first orbital rocket launch off home soil, and later in the science report, new data shows COVID-19 is now the third highest cause of death in Australia. All that and more still to come on SpaceTime.
When you download the Baker's app, you have easy access to savings every day. Get the most out of weekly sales and receive personalized coupons to save on your favorite items, all while earning 1 fuel point for every $1 spent. Baker's makes it easy to save while you shop, whether it's in-store or online, so you get the most value out of every trip, every time. Download the Baker's app now to save big on your next purchase. Baker's, fresh for everyone. Must have a digital account to redeem offers. Restrictions may apply. See site for details.
Britain's Air Accidents Investigation Board will work together with Washington's FAA to determine the exact cause of Virgin Orbit's failed rocket launch from the UK's spaceport Cornwall earlier this month. The mission saw Virgin Orbit's modified Boeing 747-400 airliner Cosmic Girl drop launch the company's two-stage rocket Launcher 1 from a pylon under the jet's port wing in the skies 35,000 feet above the North Atlantic Ocean off the coast of southwestern England. Following its launch, the first stage of the Launcher 1 rocket performed nominally.
So we have, it looks to be a successful ignition of the stage 1 engine as we make our way to space. We're actually getting towards the end of our stage 1 burn. Everything is nominal so far. We've had our pitch up on the bottom, on the burn time
Stage 1
that you
throttle
can
down,
see
Commander.
on the graphic. We have made it through max Q alpha, which is one of the most stressful physical moments for the rocket, very comfortably through max Q, and then also through our maximum heat, aerodynamic heat heating. We have made it through MECO, our main engine cutoff. That is our Newton 3 engine shutdown, is reported as nominal.
Bearing brake wires broken.
Once that was exhausted and jettisoned, the second stage lit up.
The trajectory is now tracking Launcher 1 as she makes
Stage
her way
2
down
burn 2
the
nominal.
Atlantic Ocean towards the Canary Islands.
Stage 2 trajectory nominal.
Stage 2 trajectory nominal. That means our flight path is as expected, being picked up by those ground stations. We're probably almost coming up on halfway through our Stage 2 burn number 1.
Stage 2 burn nominal.
Altitude now is looking at around about 600,000 feet, approximately 3 miles per second. Bus voltages for the batteries are nominal. We had a lower voltage while we were in captive
Switching
carry,
data source to
and
Madrid.
that's because the power was being provided by Cosmic Girl at that point before we switched over to the rocket's internal batteries. Stage 2 burn is a little longer than the Stage 1 burn, so this might take a little while for us to get to second engine cutoff 1. There are points of the flight where we don't have the telemetry coming from the rocket because we are out of view of the ground stations. Our flight software folks have implemented a store and forward on our rocket, which means that when we are out of view of the ground stations, we are storing that data so that the next time we do come in view of a ground station, we can download it and
Confirm
and
target
back
lock
through.
from Madrid. Data source switch to Madrid.
Our Madrid ground station has locked on to our rocket and is streaming the data now.
Confirm signal from Maspalomas. Switching telemetry source to Maspalomas.
Newton 4 shutdown initiated.
You just heard the call for a Newton 4 shutdown. Newton 4 is our Stage 2 engine. So that is the completion of the first burn of our second stage.
But then failed to deploy its 9-satellite payload, apparently due to a technical issue somewhere in the second stage rocket engine.
It appears that Launcher 1 has suffered an anomaly which will prevent us from making orbit for this mission. We are looking at the information and data that we have gotten.
The failed launch was also the first rocket launch attempt by Virgin Orbit outside its home base at the Mojave Air and Spaceport in California. And it comes in the lead-up to plans for a demonstration launch at Queensland's Toowoomba Airport in 2024. Britain has previously successfully launched orbital rockets. They were in association with Australia from the Woomera rocket range in outback South Australia. But the Virgin Orbit launch failure was the first launch attempt from British soil. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study shows that COVID-19 is now the third highest cause of death in Australia. The figures were reported by AusAge, a broad group of medical experts looking at the well-being of Australians before, during, and after the COVID-19 pandemic. The organisation provided a comparison of causes of deaths in recent years and says it's clear more needs to be done to reduce the excess deaths coming from COVID. This would include higher levels of booster vaccinations, delivery of safe indoor air in public settings, the use of masks in poorly ventilated indoor areas, the return to free, widely accessible testing, and a review of the mitigations being used in high-risk settings such as aged care facilities. The group warns that there's every indication that unless Australia changes its stance on managing COVID-19, this trend will continue well into 2023. So far, over 6.8 million people have been killed by the COVID-19 coronavirus since it was first detected near the Wuhan Institute of Virology around September 2019. The World Health Organization now estimates the true death toll from COVID-19 is likely to be around 16 million, with some 672 million confirmed cases globally. It's often been claimed that working from home can boost productivity, but new research shows that this was actually less likely to have been the case during the COVID-19 pandemic. The findings, reported in the journal PLOS One, are based on 37 studies, 2/3 of which were conducted before the COVID-19 pandemic took hold. Pre-pandemic, the researchers say the majority of studies showed working from home actually boosted productivity and performance, and mostly positive impacts on work life overall were noted. However, follow-up mid-pandemic studies say 27% showed positive impacts, 38% showed negative impacts, and another 38% reported mixed results. Researchers say that while more studies are now needed, especially around productivity and performance, their research indicates that non-mandatory working from home arrangements may be more successful. A new Australian study suggests that boiling peanuts may reduce most of what triggers allergies from the legumes, meaning that ultimately peanuts could potentially be reintroduced to people to eliminate their peanut allergies. The findings, reported in the journal Clinical and Experimental Allergy, are based on tests conducted on 70 children aged between 6 and 18, all of whom had peanut allergies. They were each given 12-hour boiled peanuts for 12 weeks, 2-hour boiled peanuts for 20 weeks, and finished with roasted peanuts for 20 weeks. Researchers found that 56 kids, that's 80% of the 70 participants, became desensitized to peanuts. But the authors say treatment-related adverse effects were still reported in 43 participants at 61%, 3 of whom had to withdraw from the trials. Paranormal enthusiasts around the world have been hotly debating the scenes shown in a disturbing video of a flock of sheep in Inner Mongolia in China that have been apparently walking around in a circle for at least 12 days straight. The farm owner claims what makes the entire ordeal mysterious is that although there are 34 sheep enclosures on the farm, these sheep were all from the same enclosure. number 13. And as you'd expect, that sent the supernatural snoops into a feeding frenzy, looking for any signs that this is the number of the beast, which I actually thought was 666. Tim Mendham from Australian Skeptics says, despite a multitude of supernatural explanations being offered by paranormal investigators, the real answer is a bacterial disease called listeriosis, which does affect sheep in this way. It's caused by sheep eating contaminated food, and it can be treated with an early aggressive course of antibiotics.
There's a video which has just appeared recently, which has been described as eerie and bizarre, which shows a flock of Mongolian sheep walking in circles, which they did for about 12 days. Everyone thought it's really weird. Is this paranormal? Is this sort of strange behaviour that's been coming from outer space or aliens or whatever? But the interesting thing is there is actually a disease called listeriosis, which causes exactly that circumstance. It actually makes things walk in circles and often actually favour one side more than the other. So when you get a flock of sheep that are going around in circles with this, it's normally, well, it's probably only this disease, this listeriosis, which does exactly what they was talking about. So the article I saw about this thing, about the sheep, ran through all the paranormal explanations and said, oh, by the way, this is the reason why it's happening. And it's rather sad that people make all this effort to promote a occurrence, whether it's eerie or not, with the most simple, rational and exact, accurate assessment of it that finds out the real cause.
Occam's
so
razor.
Sheep walking in circles is probably due to listeriosis. End of story.
Occam's razor. The simplest explanation is usually the best.
That's right. Occam's razor says you don't have to go to all this extent of finding paranormal explanations and things for something which is readily explained very simply. The bacterial disease. End of story.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.